Hello again, this is Mark Summers from Summers Technical Services. We're going to be talking about our GD&T assignment, and this will be multiple parts, but the first part is going to be making, as a team, there's going to be two team members. One team member makes this top plate with the holes in it. The other team member makes the bottom plate. It's going to have multiple types of screws, different fasteners, and different locking mechanisms. There's also two dowel pins, and these are all described on the spreadsheet that I've already provided. So I've got a little animation here. We'll walk through it so you can kind of see how these parts go together. So I'll start playing this top. Watch that pin at the top. That's a press fit pin into that top plate. And so that goes in, press fit, so it's sticking out the bottom of the top plate. And that's item 6 in the spreadsheet. And depending on what team you're on, it's got different fit classes for the press fit in the plate. They're all FN fits or medium fits if you're doing metric. So you'll have to go look on the provided specifications from the machinery's handbook to see what size hole you need to make sure this is a press fit with the right class. And then similarly for students doing the bottom plate, you'll have a similar pin and you'll have the same fit class for your pin. So it's going to come in press fit into the bottom plate. So those are the same pins, same nominal diameter, with the same fit class. So once we have those pins and the plates, then we're going to pull the plates together. So there's a top plate coming down with the pin, there's a bottom plate going up with the pin. And once those mate, then those are going to be fixed to one another. They're not fastened yet, but they'll be located to one another. The hole where the pin goes through on the other plate, so on this back pin, there's going to be a clearance hole on the bottom plate. And on the top plate, there's a clearance hole on the top for the pin to come through. Those are going to be guide pin fit class. That's the next column over on the spreadsheet. So you're going to, those two holes are different sizes. So that's how those go together. The next set of fasteners are going to be the ones coming in from the for the top plate. So let's keep playing this. So those fasteners going down there, those are the socket head cap screws. That's item number 3. Those come down into counterbore holes, and you'll have to figure out what size socket head cap screw you have to figure out what's counterbore and what's the clearance hole size. Some of you have close fit, normal fit, loose fit, clearance holes. So you'll determine those holes when you do your hole wizard commands. So those two holes go at the, I want to call it the 12 o'clock, 6 o'clock position. And then these next two that come down, those are the flathead screws. They'll have countersink holes, and that's item number 4 in the spreadsheet. So again, you'll have to use the hole wizard to make the correct size countersink for your particular fastener you've been assigned. Those 4 screws, those all screw into threaded holes on the bottom plate. So if you're doing the -3-03 bottom plate, you'll have to put threaded holes in the size specified on the spreadsheet so that those screws can thread into those holes. On the bottom side, we've got them rotated 90 degrees instead of 12 o'clock and 6 o'clock. It's at 3 o'clock and 9 o'clock. So now the screws from the bottom are going to come up. Again, there's 2 of the item 3 socket head cap screws that come up first. Those will pass through counterbore holes on the -03 bottom plate, and then they'll screw into threaded holes on the -01 plate. And then the same item 4 socket head cap screw, the flathead ones, they're going to come up from the bottom and again pass through clearance holes and countersink holes and then thread into the -01 top plate. So the teams are going to have to coordinate which holes are going to be flathead, which ones are going to be countersink, which ones are going to be counterbore, which ones are threaded on those. And the location of the holes, the team is going to figure out where to put those holes. So put them on a bolt circle, come up with a diameter for a bolt circle to put them on, and stagger them at 90-degree spacings so that those line up. And as far as the size of the plate, make it whatever size you want. Don't make it gigantic. Don't make it too big. Don't make it too small. You got to make sure these things, all the holes can fit. And then the thickness, the same way. You can make it whatever thickness you want. You just have to abide by the design guidelines that we talked about earlier this semester, where you need a minimum thread engagement for these fasteners. So go back and see what that minimum thread engagement is. And for different size screws, it'll be different because it's based on the major diameter of the screw. Same thing with the edge distance. The edge distance we talked about is another design rule that you want to keep the location of these holes from the edge at least 1.5 times the major diameter of the screw. So abide by those design rules as you size your plate, size your thickness, and locate that bolt circle where those screws are going to go. And then the same thing for the pinholes. You'll have to adhere to the design rules as far as edge distance goes. Finally, there's 2 hex bolts, and each one of them has a flat washer, which is going down there, and there's a split lock washer going down. So that'll ensure that the load, when you tighten these things up, the load will be distributed through that flat washer, and the lock washer will keep this thing from vibrating loose on us. And then these are hex head bolts. These are item number 5. And all of the fasteners, all the dowel pins, all the washers, we'll get those from the design library that's built into SolidWorks. So this whole project is all going to be self-contained within SolidWorks. And so then to finish the video here, those fasteners go down and they'll screw in, they'll pass through the, let me get it back down here, they'll pass through clearance holes in the -01 top plate, and those will be based on the close, normal, loose column where it says screw clearance hole size. Those close, normal, loose apply to all these fasteners. And then again on the bottom plate, there'll have to be threaded holes for you to screw those hex head bolts in and complete your assembly. Once you get the model completed, you'll start on a drawing for your model, and we're going to take advantage of positional characteristic like we did on assignment 4A. So we locate those holes, and you're going to calculate what the positional tolerance is in your feature control frame based on the examples I gave in the lecture notes coming from ASME Y14.5. So you'll come up with those numbers. I'll be checking all those numbers, all the sizes of the holes, all the tolerances on the holes will be the locational, the size of those holes will be plus or minus 5 thousandths, but you'll be calculating the positional tolerance when we do the GD&T calculations for how to position those holes so we ensure that the screws all fit both plates. We'll also define datums. So here's how we're going to define the datums on the parts. The bottom surface where these two mate together, that's going to be datum A. Datum B will be designated by a feature of size, which will be the length of this edge here. So define datum B with the feature of size dimension for this distance here, and then datum C will be defined as by the feature of size dimension for this width here. So the datum B and C will go right through the middle of the part, and you'll locate those holes from datum A. You'll be perpendicular to datum A, and then you'll have dimensions coming from datum B and datum C to locate each one of those holes. And when you do the drawing, we'll be using ordinate dimensions, not the linear dimensions we've been using up till now. And then maybe finally, decide on a material to use. You can use any kind of aluminum alloy, any kind of carbon steel alloy, or any kind of stainless steel. Make sure 2 team members use the same material, which means you'll have the same material call out on your drawing and the same finish call out on your drawing. So if you're using aluminum alloys, you're going to use a sulfuric anodized finish. If you're using carbon steel, you're going to use a zinc plate finish. And if you're using stainless steel, you'll use a passivation finish. So coordinate with your team members to get that. So the deliverables are a part model and a drawing file, SolidWorks file, and then you'll do a PDF, 11 by 17 PDF print on 11 by 17. You'll use a B-size sheet, to do your drawing. And so those 3 items will be the deliverables. And then after that, we'll start another assignment where you can make the assembly model. So we'll talk about that in a separate video. So hopefully that was helpful. If you have any questions, stop by during office hours or talk about it in class. And we'll talk to you in the next video.